Today on Remaking Super Mario World in Godot, a whole bunch of things. I'll be figuring out how the status bar, power-ups, pipes and the camera work in the original game, and putting it all together in Godot to make my first complete level. Hi there, I'm Y, and to teach myself game development, I'm remaking Super Mario World in the Godot engine. And if I want to finish that anytime soon, I'd better pick up the pace. So there's gonna be a lot to cover in this video. I'll go into way too much detail on how Super Mario World handles the status bar, the camera, power-ups and level transitions, and then recreate them all in Godot as accurately as I can. Can I make this actually feel like a playable level? The short answer is, yeah, pretty much. The long answer is coming right up. Last time, I left off with this. And if you look very closely, you'll notice that this part isn't quite what it looks like in Super Mario World. This is the status bar, also known as head-up display, HUD, or whatever term is dearest to your heart. And it's about time I make it look like the real thing. In Super Mario World, the status bar is on layer 3, which is also used for background effects like these scrolling clouds. To make sure it's always visible, the game uses an interrupt to change the layer 3 properties as the frame is being drawn. The top of the screen is stationary and above everything else, and the bottom can be transparent and moving. That's how the status bar and the clouds can exist at the same time, though they still can't overlap. In Godot, of course, I don't need these tricks, because I get as many layers as I want. I can just add a canvas layer node with the status bar image on it, and there we go. Now I just need to make it show numbers. I could use text labels and then try to get the font just right, but I think I'll do it with sprites instead. I'm gonna make an animated sprite, where the animation frames are digits from 0 to 9, and then use them in a number display scene that can create these sprites on the fly to show any number I want. In this case, I want the number of coins, which I'm keeping in my autoload script called GameState. So anytime Mario gets a coin, that script sends out a signal, and the display reacts to that by updating the number. And here's something neat I learned about. When you declare a variable in a class, you can also give it get and set functions, and they're gonna run every time you access or change the value. So no matter where Mario gets a coin from, I can emit the signal in this one place. And of course I can do the same thing for lives, score points and the timer. But I'll keep the timer at 0 for now, because the last thing I need is more deadlines. This is starting to look a lot more like Super Mario World, but there's a much less obvious thing that's been off all this time. Mario's in the wrong place on the screen. Seems like I need to make a new camera system. So, as you do with cameras, let's look into it. A video game camera is anything that decides what part of the game to show on the screen. The simplest camera just follows the player and keeps them exactly in the center. But that means anytime I make the slightest movement, everything on screen moves with it, and that gets annoying pretty quickly. So, cameras usually have a static region, also known as dead zone, blind spot, or whatever term is dearest to your heart. When the player is inside this region, the camera stays still, so we have less unnecessary movement. And when the player is outside, the camera moves so he's just on the edge. Godot has a built-in camera 2D node, and it lets you define the static region with these drag margin variables. Job done, right? Well, not if I want to be accurate to the original game. Because the camera in Super Mario World has a lot more going on than you might think, and it took me ages to wrap my head around. How the camera works in Super Mario World. The game actually has two static regions, one for horizontal movement, one for vertical movement. Let's look at horizontal movement first. The game wants you to see more of what's ahead of Mario than what's behind him, so the static region is not in the middle of the screen, but a little off-center, and it can also move, depending on Mario's direction. Anytime Mario ends up outside of the static region, the camera instantly snaps into place so he's inside again. Usually he's only a pixel or two away, so that snapping looks like smooth scrolling. If Mario's to the right of the static region and he's facing right, the static region moves over to the left, if it's not already there, so you can see more of the right half of the screen. And likewise, if he's to the left and facing left, the static region moves over to the right. That actually is smooth movement, not instant snapping, otherwise it would look like this. And the static region really only moves when Mario's facing a certain direction. So when he's spin jumping, changing direction all the time, it actually moves in short spurts. You can also move the camera by yourself with the L and R buttons. That makes the static region cycle through the familiar left and right positions, as well as all the way left and all the way right. As soon as Mario moves, the normal rules kick in again, so when Mario turns around, the static region goes back to being closer to the middle. For vertical movement, the camera also has a static region that it wants Mario to be in, but this one is fixed to the screen, it doesn't move. And it also doesn't snap to its target position, the camera just slowly moves up or down until it catches up with Mario. The camera can always move down to catch up with Mario, but moving up is only allowed under certain conditions. For example, when Mario is on the ground or swimming. Once those conditions are met, the camera can start moving, and it doesn't stop until it catches up with him, even if the conditions stop being met along the way. And some levels have a special setting, where the camera doesn't move up at the very bottom of the level, unless Mario's jumping at full P speed. So it's possible to make Mario go off screen without the camera moving. So, how do I copy all of that over to Godot? Can I just use the built-in camera? Well, because the static region can move, I definitely need to change it through code. I can attach a script to the camera and try to change the drag margin from there, but it looks like Godot doesn't take kindly to that. I think I'm better off making my own camera from scratch. And the documentation actually tells me how to do that. Make a node 2D and set the camera position through the viewport's canvas transform variable. How the camera moves is now entirely up to me. And of course I want it to move like in Super Mario World. From there it's just a matter of writing code. For some definition of just. Here's a fun detail. When you scroll the screen with L and R, the game pauses, except for the camera itself. Pausing in Godot is easy. And for each node I can specify whether it should be affected by pausing or keep running. Here I want the camera to keep running, but other times I might want it to pause too, like when you actually press the pause button. So what I'm gonna do is make a pause manager class to handle that. I can give it a list of exceptions, and then it will set those nodes to keep running before it pauses the game, and restore the default when it unpauses. After a lot of research, a lot of help from people, and a lot of bug hunting, I ended up with this. It works really well, and I'm actually pretty happy with it. But I'm also glad to put all this camera stuff behind me. I should mention that you don't have to code everything from scratch. For the camera, people have recommended an add-on called Phantom Camera, which seems a lot more flexible than Godot's built-in camera. I don't think it's right for this particular project, but in general, it's always a good idea to check Godot's asset store. I think this camera really improves the game feel, but it is a pretty subtle change, and I'd like to make some more obvious progress now. And if there's one obvious thing that's been missing from this Mario experience so far, it's power-ups. In a way, power-ups are the opposite of the camera. The camera is really intricate, but making it in Godot is just a matter of writing code. While power-ups are pretty straightforward, but I need to put some thought into building them. If you've played a Mario game before, chances are you know how power-ups work. When Mario gets a mushroom, he grows big. And when he gets hurt, he shrinks back down. Some Mario games actually keep him big when he gets hurt with a fire flower or cape, but in Super Mario World he always goes back to being small. So one thing I definitely have to do is keep track of Mario's power-up state. And depending on that state, Mario needs a different sprite and a different hitbox. As seen in the last episode, Mario's hitbox isn't just one object, it's a handful of rays, 6 interaction points and an area 2D. And pretty much all of those need to change when Mario is big. I could set all of their positions and sizes through code, but that would be a lot of hard-coded numbers, and I couldn't change them in the editor by dragging shapes around. So instead, I'm gonna make 2 versions of all the nodes, one for Big Mario, one for Small Mario, and then I'll just enable the ones I need and disable the ones I don't need. I'm also sorting the nodes into 2 groups. Groups are a useful Godot feature for when you want to do something to many nodes at once. Instead of searching for them or getting each one separately, you can get them all with just one line of code. Now this should run anytime Mario's power-up state changes, and also when he's ducking, because that always makes him use the small hitbox. And that's where setter functions come in handy again. I don't need to add code to all the places where I change the ducking and power-up state variables. I can just make setter functions for them, so anytime they change, Mario's hitbox will update along with them. Now feels like a good time to add the fire flower into the mix. The hitboxes are the same as for Big Mario, but his sprite has different colors. I think I could do this using shaders, and I'll definitely try that later, but for now I'm just gonna make a separate fire sprite and show that when needed. When Mario has firepower, you can press X or Y to make him shoot fireballs. That's as easy as making a new fireball scene, although the bounce physics are surprisingly complex, and spawning an instance of that scene at the press of a button. In Super Mario World, there can only be 2 fireballs on screen at a time. That's partly to save on memory, and partly to prevent things like this. I could be smarter about it and remove that limit, but 2 fireballs is actually pretty reasonable, so I'll just keep it. The only thing that's missing, well, apart from the feather power-up, but I'll come back to that, the only thing that's missing is animations. When Mario touches a power-up, he plays a short animation while the rest of the game is paused. Here's where my pause manager comes in handy again. This time I want to pause everything except for Mario's sprites. When the animation finished signal fires, I want to unpause. And here's another thing I learned. You can use the await keyword, and the function will essentially pause until the signal fires. Call it coroutines all you want, this will always feel like magic to me. The power-ups themselves, the mushroom and the flower, aren't too hard to make. They're just entities. Making them spawn from blocks is a little more involved. It took a while to get the movement and interaction right, but in the end, I'd say power-ups are working pretty well now. Now how do I go from this section to the next? Ah, pipes. This wouldn't be a true plumber platformer without going into pipes and popping up somewhere completely different. Let's start with that first part. In Super Mario World, pipes are just solid foreground tiles, and pipes that Mario can enter are separate tiles. In Godot, instead of implementing them as blocks, or even as entire pipe scenes with their own graphics and collision, I'm just gonna make a pipe entrance area that I can put on top of anything. When it's a horizontal pipe, the area should have a different shape. Ideally, it should change in the editor too, so I can see the pipe direction at a glance. And I can do that by making this a tool script. That means the script also runs in the editor, and any changes I make will show up instantly. That way I can also add a label to the pipe that's shown in the editor but hidden during gameplay. When Mario touches this area and I press down, it changes his sprite, makes him go behind the foreground, stops processing physics and inputs, plays a sound, and makes him move downwards until he's disappeared into the pipe. And now it's time to leave the comfort zone. Until now, the whole game has consisted of this one level, but now I'm gonna have to build a whole new level for Mario to end up in. Ah, how I've missed tile set building. Now that I've got a second level, I can give its path to the pipe entrance object, so that's gonna be its destination level. In Super Mario World, the destination level is a property of a 16-tile region, so every pipe in the same region would have to lead to the same level. But in Godot, there's no reason I can't just give each pipe its own settings. So how do I make the pipe load the new level? How do I change the current level to this one? Basically, I just set the current scene variable to the new level scene. But with pipes, I need some more things to happen before and after that. Step 1. Save the state of the old level, for example Mario's power-up state, so it can carry over to the next level. I'm saving that in my game state autoload. Step 2. Actually load the new level. Step 3. Apply the saved state to the new level. Step 4. Tell the new level that Mario came from a pipe, so it can start with the pipe animation. I'm gonna wrap all of that up in this level switcher class. So in the pipe code, I can just call this one change level function. I know I'm still missing the fade out effect and the mosaic, but I think I'll save that for when I get around to shaders. For now, I kinda like how snappy this feels. Now this looks like it works pretty well, until I go back to a level I came from and notice all the coins I collected are back. In the original game, they don't respawn when you come back, otherwise you could collect the same dragon coin over and over. So I also need to save a list of things you collect, not to carry over to the next level, but for when the same level gets loaded a second time. That's also called item memory. In Super Mario World, item memory is pretty limited, because memory in general is pretty limited. The game doesn't track every tile individually, but columns of tiles. When you collect one, the whole column gets marked as collected, and when you come back to the level, all of them will be gone. And often different rooms will share the same item memory, so collecting a coin in one room can prevent things from spawning in another. Why are my coins not showing up? Is one of those common questions from beginner ROM hackers. In Godot, of course, I'm not that short on memory, so I can actually track every object in every level individually. When I collect something, it fires the item memory changed signal with the position of the tile, and the level listens to that signal and saves it to a list of positions where something was collected. Then, when the same level is loaded again, goes through all the blocks in the level, checks if the position matches, and if so, makes the block erase itself. And there we go. By the way, with how I've set it up, the player is a child node of the level, so each level technically has its own separate player, and all the relevant states are carried over between them. That feels a little inelegant, so I think I'll come back to this later. This is getting pretty close to being an actual Super Mario World level. You know, except for most of the enemies in it. Last time I honestly left them in the very basic state. And I've been meaning to give blocks an overhaul too. So for the home stretch of this first level, let's go and do that. The first thing I want to do here is make some more types of blocks. And actually, I also want to change the way they work. Last time I implemented blocks purely through inheritance. That's where you have some base class, and other classes can inherit all its properties and define their own on top, so you don't have to write the same code twice. I had classes like Hittable Block for blocks that Mario can hit, and Springy Block for blocks that he can bounce on. But what if I want a block that's both hittable and springy? Because that actually exists in the original game. I can't inherit from two classes at once, at least not in Godot. So what I'm gonna do here is use composition. That means the properties and behavior aren't stored in the parent class, which a block can only have one of, but instead they're in separate objects which can be child nodes of the block. That way, instead of having everything handed down, blocks can now pick and choose which properties they want, and as many as they want. For example, if I want a hittable node block, I can take my standard block scene, add the hittable component and springy component to it, and there we go. And I could add more components if I wanted to, like the spin jump breakable component, so it would break when Mario spin jumps on it. Blocks don't have to be stationary squares either. I can now make dragon coins or flying question blocks just by adding the right components. I could even make flying dragon coins. By the way, I'm still using inheritance. All blocks inherit from the block class, which defines the basics that all blocks have in common. And all components inherit from the component class. Inheritance and composition can go hand in hand. And I should also mention, this is not a full-on entity component system, if you've heard that term before. I'm also not sure it's an example of favor composition over inheritance, if you've heard that before. I think it's really just making use of Godot's node structure. Here's how it works in a bit more detail. The component class defines a function for adding itself to the block's list of components, and the functions that run when Mario touches the block from various directions. They're empty by default, so the actual components can override those functions. For example, the hittable component makes the block it belongs to bounce when Mario hits it. The block class has a list of components, and when Mario touches the block, it goes through all of its components and calls one of those predefined functions, depending on which of his interaction points is touching the block. By the way, I spent ages obsessing over the springy component used in node blocks. Node blocks are special because, although they bounce Mario upward, they don't do it immediately. They only do it when their own bounce animation has finished. The block actually pulls Mario down with it, and during that time he can't jump, unless he walks off before he bounces. That took me ages to get right, but in the end, I'm really happy with how blocks work now. Let's move on to enemies. For them, I'm actually still not using composition. I'm just giving the base enemy class some more functionality. It now has predefined functions for all kinds of behavior. Being jumped on, being spin jumped on, being slide killed, being hit by a fireball, and so on. So for a lot of simpler enemies, I don't have to write any new code. For example, if I want to make a spiny, I just inherit from the enemy scene, select what should happen when Mario jumps on it, spin jumps on it, and so on, and there we go. And for more complex enemies, there are predefined functions like touched by player or touched by fireball that they can override with their own behavior. From here, it's just a matter of making a couple more enemies, Rexes, Banzai Bills and Sliding Koopas, and populating the level with them. And now I finally have everything I need for a fully functioning Super Mario World level. Can you tell which one's the original game and which one's my remake? It's not perfect, but I think it's pretty convincing. The game feel is definitely there now, and I'm really happy I could get it all to work. As always, there are a lot of mini adventures I didn't get to mention in this video, and there's still a lot of work ahead. For the next video, I think I want to tackle the overworld map, because that seems fun, and also look into shaders, because that seems useful. And probably take care of some more basics too, like water physics, because that seems, well, necessary. This is still not a complete game by any means, but we're getting there, one video at a time. Thank you so much for watching. If you enjoyed this video, you're a freaking nerd.